Hi everyone. Today we look at the representation of strings in the Java programming language. Java provides three different classes that you can work with whenever you need to work with text data. We got the character class, which allows you to work with single characters. We've got the string class that allows you to work with strings that are fixed in length and cannot be changed. And then the string builder or string buffer classes, both of which are used for storing and manipulating strings, the length of which you can change. And we'll take a look at all of these three in the next few slides. So starting with the character class, it's one of those that are included with the default library. You don't have to load or import any libraries in order to use it. The syntax is char for character, and you come up with a suitable identifier for your character variable, and the data that you store is going to be represented with a single character enclosed in single quotes, single quotation marks. In this case, we assign t to my char, and then we display the string the character is space t. Some of the methods that you can use with the character class include isLetter, which tells you whether the specified character is a letter or not. isDigit will return true if you're looking at a digit and false otherwise. isWhitespace will let you determine if the character is a white space, something like a space or a tab. isUppercase determines whether the character you're calling this method on is an uppercase character. isLowercase tells you whether the character is a lowercase character. toUppercase and toLowercase allow you to convert the character you apply this method to uppercase or to lowercase respectively. And then toString returns a string object that represents the character value, so that you can use it in methods that expect strings as arguments. And here's a little piece of code that demonstrates some of the methods. We assign myChar the value t, and then in the couple of if-else statements down here, what we're going to see is on the first one we call isUppercase on myChar, and that actually will return true because t is an uppercase character, and we're going to print t is uppercase. Down here is lowercase, that will return false, so we're going to skip this part. We're going to come down into the else part and we'll print t is not lowercase. Now the string class is actually a class. I did tell you in class we can treat it more or less as a primitive data type, but we should not forget that it's implemented as a class, which means that we're going to have quite a few methods available to us that we can use with the string objects. Please do note that the strings are immutable, which means they cannot be changed once they're created. And down here we got two different examples of creating strings, of declaring and assigning values to string variables, and they're both correct, so they're both valid. String example equals this is also a string is gonna declare example is a string, and it will assign this text to it. Greeting has been declared and initialized with the new keyword, and that is perfectly fine as well. So greeting is going to be equal to my first string. Like I said with the previous slide, you got the option of either creating the string with the help of a literal, which is what we're doing here, or the new operator. So once strings are created, we cannot change them. We cannot change a part of the string or the whole string, and here is an example of what goes on in the computer memory. So once we declare the string called s and we assign Java to it, s is going to be a pointer to a location in memory that has the string Java. If we now set the value of s to be equal to HTML instead of Java, we're not changing the value of the original string object. It becomes unreferenced, and it will be cleared by the Java garbage collector, as actually becomes a pointer to a brand new string in memory, which is HTML in this case. Since strings are immutable and since they're frequently used, the Java virtual machine is implemented in such a way so that if you use multiple string variables to which you have assigned the exact same actual string text, the way that this is going to get handled is your pointers or your string names, variable names, will be pointing to the exact same memory location, and the term for this is called interned. So these are interned instances. How does this work? In the example down here, we have string s1 set to equal to welcome to Java. S1 gets created, welcome to Java gets saved in memory. S2 is declared with the new string welcome to Java. Okay, so that gets a new chunk of memory set aside for welcome to Java. This is not a literal, okay, so we're creating in a different manner. And then S3 has been created using the string literal welcome to Java. The Java virtual machine is going to see that, and instead of setting aside another chunk of memory for S3, it's simply going to make that S3 pointer point to the same memory location where S1 is pointing. So system out print line for these two statements is going to print on the first line S1 equals to S2 is, and that will display false, because this is a comparison of the memory pointers, and these two are pointing to two different locations. In the second case, S1 equals S3 is, and that will return true, because S1 and S3 are pointing to the same memory location. Now here are some of the Java string methods. You can view the list, but let's take a look at each one of these individual with some examples. The length method will return the length of the string. So if message has been assigned the value welcome, its length is going to return 7, because that's how many characters we have in that string. Char at tells you what character is currently assigned to an individual element of the string you're calling this method on. So for example, if message has been assigned the value welcome to Java, message.char@0 will return W, capital case W, because that's what has been stored at that location. Message length will return 15, because that's how many characters there are in this string. And the very final one, message.char@14, is going to return lowercase a. Alright, comparing strings is normally done with the equals method. So if you want to compare two strings and find out whether they contain the same information, you're going to be using the equals method. So if s1 dot equals s2, then do something. In this case, this is going to return false, because s2 happens to start with a lowercase w, whereas s1 starts with a capital W. Down here, if s1 equals s2, again this is going to return false, because this compares the pointers, the memory pointers, and these two are actually pointing to two different locations in memory. The equals method does not perform an alphabetical comparison, it performs a lexicographical comparison, which means the comparison takes place based on the integer Unicode values of the characters. Okay. Lowercase w and uppercase W have different Unicode codes, and that's why this is going to return false. Equals ignore case is going to compare the two methods, ignoring the case. So in this example here, we have three strings, string 1, string 2, string 3. They're initially having assigned the values of apple, mango, and apple, all uppercase. Down here, First we compare string 1 with string 2, ignoring the case. That would return false because apple and mango are not the same. Then we compare string 1 with string 3, ignoring the case. Now that would return true because we have apple in both of these. Then we compare string 1 with welcome. That will return false because there's no welcome in string 1. And then we compare string 1 with ignore case apple. Again, that would return true because string 1 is actually apple. And finally, string 2 compared with mango, all lowercase, will return true because we're using the equals ignore case method. Compare to allows you to compare two strings character by character and return 0. If the strings are exactly the same, returns a negative number. If the calling object is less than the argument based on the Unicode values of the individual characters in the string, and a positive number if the calling object is more than, again, in a lexicographical comparison. So over here we're comparing again welcome and welcome. First one with a capital W. If S1 compared to S2 is greater than 0, right now I'm not really sure whether the uppercase W comes before the lowercase w in the Unicode table or vice versa. So I have to actually run this in JGrasp to see exactly which part of the if will be executed. But in order for this to make sense, again, we do need to know the Unicode values of the characters we're comparing. String concatenation, so far we have been using the plus sign to concatenate strings. It's identical to the concat method. So you can use concat and concatenate a bunch of strings, or you can just use the plus sign to do the same. Extracting substrings. On occasion you may find a need for extracting one or more characters from a string. You can use the char at along with the substring method to accomplish this. So in this example here we've got a couple of strings S1 and S2. First one has been initialized to welcome to Java. The second one is going to get all the characters from the first one starting at location 0, 11 characters of that string, and then it will also add HTML at the very end. So S2 will be assigned the value welcome to HTML. A few more examples showing you how to convert and replace strings. To lowercase is going to return a new string. In this case, if we're applying it to welcome with a capital W, you'll end up with just a welcome with a lowercase for all of the characters. To uppercase does the opposite, so it returns a value that's all uppercase characters. Trim is going to trim all the spaces on the left and the right. So if you start off with this kind of string, then you end up with just the word welcome. Replace is going to replace, it will return a new string that replaces the character, all occurrences of the character E with an uppercase A. So you can see here both E's have turned into uppercase A's. Replace first is going to find the first occurrence of this character, or I'm sorry, substring, and replace it with the second substring. So starting with welcome, we'll end up with what you're seeing here at the very end. Replace one string with another is going to replace all of the occurrences of the first one with whatever you have specified as the second argument. And likewise for the final one, you do the exact same thing. Region matches is another method that can be used this time to test whether two string regions are the same. It's going to take 4 arguments: the position in which you start from the initial string, the one that calls the method, then the other string being compared, the position to start in the other string, and then finally the length of the comparison. So take a look at this. Our initial string is ABCDE. There's five characters in it. The second string is XXBCDEF. Region matches in this case will return true because we start let's see, position 1, that's the second character. We start at the B in the initial string, and then in the second string we start at position 2, which is the third character, again B, and we compare exactly 4 characters, B, C, D, E. Those are precisely the characters down here, so this one function called down here is going to return true. Finding a character or a substring in a string, here's a bunch of methods that we can use for that purpose. Index of will return the first occurrence of that character. Index of will return the first occurrence of that character starting with the from index in the string. Index of S allows you to find the first occurrence of an entire string within the string calling the method. And index of with the second argument basically tells Java where to start looking for that string. Last index of returns the index of the last occurrence and of a character if you pass along a character, or a string if you pass along a string as the argument. Here are some examples for the string welcome to Java. Index of W will return 0 because that's where the first W occurs. Index of lowercase x returns a -1 because there is no x. Index of O starting at number 5 will return 9 because that's where the second O appears. Index of the word come is going to return 3 because that's where that string occurs. Index of Java starting at 5 returns 11. And index of Java lowercase j 5 returns a -1 because there is no such string. And last index of A is going to return 14 because that's the last occurrence of the character A. Converting characters and numbers to strings, we can do that with the help of the value of method. So you pass along a number, and the value of method is going to basically return a string based on that number. Now, string builder and string buffer are available in Java for you to use whenever you need to customize or change the length of your strings for whatever reason. What's the difference between these two? String builder is said to be more efficient, and if you ever need to use one of these, my recommendation is that you stick with string builder. String buffer is thread save. This is something you need to worry about only if you do multi-threaded programming, which is an interesting thing to do with Java, but it's well beyond the scope of our class. We're not going to be doing multi-threaded programming in this class. You're going to use these whenever you need to change the contents of a string. They're a more flexible alternative to the string class. And the things that you can do with them, we're going to see their methods in just a moment, but you can add, insert, append new contents into a string buffer, whereas the string objects are fixed, they're immutable, and cannot be changed once they're created. So the string builder methods, there are several ways you can construct a string. Here are the short list of the methods, but here's a good set of examples that can help us understand how string builder works. And I will have a separate handout for the string builder class that you can look up in the weekly module to learn more about this particular class. So here we create a string called string builder with a lowercase s. So all the things we're about to do are things we're doing to this string builder string that's spelled with a lowercase s. Initially, we initialize it to just welcome to with a space. Then the first thing we do is we append Java to it. It becomes welcome to Java. Then we insert at location 11 HTML end, and so the string becomes welcome to HTML and Java. And then we delete 3 characters starting at location 8. That's the TO and the space, and so we're going to be left with welcome HTML in Java. Then we delete only 1 character, location 8, which happens to be the H. We are left with welcome TML in Java. Then we apply the reverse method, which simply reverses the entire string for us. Then we replace the current contents with welcome to Java, starting at location 0 and going for the length of the string. So at this point it becomes welcome to Java. And then we replace the Java part with HTML with the help of the next function call. And this final method call, actually the comment here is incorrect, and it's an image, I can't fix it, but we are setting the character at location 0 to lowercase w, and that is correct up here, but we haven't changed anything else, so this should read welcome to HTML, starting with a lowercase w. Alright, and like I said, in the weekly module you'll find another handout that is going to discuss the string builder class further. That wraps up our string discussion for this week. Thank you very much for